Alright guys, this is lesson 52. So now, just as a reminder, remember that the inverse of an exponential function is a logarithm. So anytime you ask me, what is a logarithm? I'm always going to tell you, well, that's just the inverse of an exponential. Alright, so I'm not going to try to reteach you this stuff. You should already know that. So we're going to go straight to the derivative of a logarithm. Alright, so the derivative of a natural log, so the derivative with respect to x, of the natural log of u, assuming the u is a differentiable function with respect to x, right? The derivative of the natural log of u would be 1 over u times the derivative of u with respect to x. All right, so one more time, this is a important derivative right here, and I will say that the natural log is something that appears over and over and over as you go into calculus, right? So don't forget that du dx is the derivative of u. Okay, so let's just go straight to a few examples here. So I'm going to try to take the derivative of this right here. Okay, so the derivative of this would be, remember, the derivative of this would be equal to 1 over u. U in this case is all of this. Right? So u in this case is everything inside that natural log. So that would be x cubed plus 1 times the derivative of x cubed plus 1, which would be 3x squared. Alright, so the answer would be 3x squared over x cubed plus 1. That's as simple as that. Okay? Now let's go to the next one. So I'm going to write this out a little bit so you can, in case you're confused. So if you have the natural log of sine of x, right, inside this natural log we have a differentiable function. So u is sine of x. And the derivative of sine with respect to x would be cosine of x. Alright, so keep that in mind as I'm going to follow this formula one more time. So the derivative of this will be, I'm going to write this as dy dx. There's no, I'm just changing it up for you so you'll recognize the notation. So dy dx, which is the derivative of y with respect to x, is equal to 1 over sine of x times the derivative of sine, which is cosine of x. Alright, and if you think about it, cosine of x over sine of x, that's cotangent of x. So dy dx is equal to the cotangent of x. And that's it for that. Okay? Alright, let's go to the back. Now in the back, the reason that we did lesson 50, alright, and remember I didn't actually record anything for 50, I just did it so, I just took a picture of it so you can look at it. 50 was just a review of the stuff you did in pre-calc, alright, the rules of logarithms and exponents. So remember that this right here, the square root of the natural log of x is the same thing as natural log of x to the power of 1/2, right? So keep that in mind as we're going to do this. So now, if we have this natural log of x to the power of 1/2, then we have a chain rule here, where the outer function is 1/2 and the inner function is natural log of x. So the derivative of f of x would be 1/2 times the natural log of x to the power of negative 1/2. Alright, so this right here is the derivative of the outside. So it's the derivative of the outside defined at the inner part times the derivative of the inside. So the derivative of natural log of x would be 1 over x times the derivative of x, which is 1. Right? So if I try to simplify this, notice that I would have 1 over 2, right? This is the 1/2. This is a negative exponent. So I'm going to bring that to the denominator of this. So this is the natural log of x. And this x is also on the bottom, alright? So I'm going to write it here, but that kind of looks weird to me. So I'm going to rewrite this as 2x times the square root of natural log of x. So, excuse me, on this one you don't need to know anything about 50, but on the next one it would be very useful if you do. Alright, now if you think ahead a little bit, and if I say the u is all of this stuff, then the derivative of x minus 1 over the square root of x minus 2, you would have a quotient rule. And on top of that, you would have a chain rule, because if I take the derivative of the square root, I'm gonna have to use a chain rule. All right. So to get around that, what I can do before I take the derivative, right, would be to rewrite this. If you remember the rules of logs, right? If I try to expand this, if I expand this natural log, I can rewrite this as the natural log of x minus 1 minus the natural log of x minus 2 to the power of 1/2. Now, to go further in that, I'm just going to rewrite this. There's nothing else you can do to this. But if I want to keep expanding this, remember, if I have a power here, I can bring that power in front of the natural log. So I can rewrite this as 1/2 natural log of x minus 2. Now, remember that this right here, this is still just y. All right, this is just y. I have not taken the derivative yet. I just did that because that's going to be a lot easier for me to take the derivative of this instead of taking the derivative of that, right? So now I'm going to take a derivative of something that's much simpler. All right, so make sure you go over 50, lesson 50, if you don't understand what I did between here and here. All right, so now the derivative of this would be dy dx, and that's going to be equal to the derivative of natural log of x minus 1 would be 1 over x minus 1 times the derivative of x minus 1, which in this case, the derivative of x minus 1 is just 1. Right, so I'm not even going to write that because I don't need to. Right, so now this is going to be minus, and I'm going to write the 1/2 here. Remember, the 1/2 is just a constant. You don't have to do the product rule. I mean, you can, but you don't have to. All right, so now the derivative of x minus 2, the natural log of x minus 2, would be x minus 2 here. Okay, well, let me rewrite it like that. I feel like maybe I'm skipping too many steps here. So what I wrote was correct anyway, but this would be 1/2 times 1 over x minus 2, because remember, to take the derivative of the natural log of x minus 2, that would be 1 over x minus 2, okay, times the derivative of x minus 2, which in this case is also 1, so I'm not gonna rewrite that. Okay, if I simplify this, then I would have 1 over x minus 1 minus 1 over, now this 2, I can multiply that x and that 2 with this 2. So this would be 2x minus 4. And I'm just going to leave it at that. Okay, so that's my answer. I guess potentially they could look for the common denominator, but let's not do that. All right, we'll just leave that for another time. All right, on example 5, they are telling us at least to use the laws of logs to help differentiate this. So before I even take the derivative, all right, I'm just going to simplify using the rules of logarithms. All right, so I'm going to try to expand this. So remember, so this is a lot of steps, so maybe I should take a couple of steps just to remind you. All right, if you have, notice that on top you have x times all of this. If inside the natural log you have two things multiply by one another, what you can do is you can write it like this. That's the natural log of x plus, all right, so if you multiply, you can add two logarithms. The natural log of x squared plus 2, okay, square, and then divide. So as soon as I divide, I can subtract. All right, so I'm going to subtract the natural log of 2x cubed minus 1 to the power of 1/2. All right, so now if I have a power here and a power here, I can bring those powers in front of those natural logs. All right, so I'm just going to rewrite this. So this is f of x. This is the natural log of x plus 2 natural log of x squared plus 2 minus 1/2 natural log of 2x cubed minus 1. Remember that 1/2, this 1/2 came from here, from bringing that in front. All right, so remember at this point I have not taken the derivative. This is just me simplifying this right here. So now that I'm in the most simplified version that I can think of, okay, I can take the derivative, and the derivative is going to be much easier. So the derivative of this would be, the derivative of the natural log of x would be 1 over x times the derivative of x. The derivative of x is 1, so I could write it here at times 1, but I'm not going to write it. And then plus 2 times, this 2 came from here, by the way. The derivative of x, the natural log of x squared plus 2 would be 1 over x squared plus 2 times the derivative of x squared plus 2. The derivative of x squared plus 2 would be 2x. Okay, now minus 1/2 times the derivative of the natural log of 2x cubed minus 1. Remember, to take the derivative of this, you would have 1 over 2x cubed minus 1 times the derivative of 2x cubed, which will be 6x squared. Now the derivative of this negative 1 would be 0, so I'm not even going to write that. Alright, so now all I'm going to do here is just simplify everything. Notice that this right here, well, let me wait. The derivative of this would be 1 over x. This right here would be plus 4x, because I multiply that 2 and that 2x, over x squared plus 2. Minus, now notice that this 1/2, I can actually reduce this with that 6, so that would become a 3. So then I have minus a 3x squared over 2x cubed minus 1, like that. Okay, now finally on example 6, are we going to take the natural log of an absolute value. Now if you remember, if anytime you've taken the derivative of a absolute value, what you're going to do here is you're going to write two different equations, one with the x just like it is, okay? So this is like a piecewise defined function. We're going to split this up into a piecewise defined function. And I'm going to write this as a natural log of negative x, where x is less than 0. Okay? Alright. So now what you do after that, alright, is you're just going to take the derivative of this, you're going to take the derivative of that. Simple as that. So I'm going to take the derivative. So this right here would be equal to 1 over x, right? The derivative of natural log of x is 1 over x times 1, so that's it for that, if x is greater than 0. And the derivative of the natural log of negative x would be 1 over negative x times the derivative of negative x would be negative 1 if x is less than 0. However, notice that this would be a negative times a negative, so you still get 1 over x. Okay? So regardless, this is equal to 1 over x. So that doesn't really change. Notice that this and this is the same, right? There's no difference. So because of that, because this right here, if you take the derivative of natural log of x, you get 1 over x, and if you take the derivative of natural log of negative x, you still get 1 over x, because of that reason alone. Therefore, the derivative of a natural log of the absolute value of x is just going to be 1 over x. So why am I telling you this? Well, if you're taking the derivative of a natural log of an absolute value like this, it doesn't matter what's inside this absolute value, you're just going to do exactly the same thing that you did up there. Alright? It's exactly the same, so there's no difference. So this is another one you kind of sort of need to remember. Okay? Alright, well, if you have any questions, let me know. Make sure you go over lesson 50 if you know, expanding logarithms is confusing to you. You just need to kind of remind yourself of how to do that. Alright?